Welcome to the CompTIA A+ 220 1101 or Core 1 exam. This is Objective 3.4, Motherboard Expansion Slots. If you look at the motherboard, there are a lot of different components that are attached to these systems. There's a CPU and memory and storage and expansion slots. And there needs to be some way that these different components can communicate with each other. There are also times when we might want to add functionality to our motherboard by adding an expansion card into one of the available slots. And that expansion card needs some way to communicate with the memory and the CPU. Many of these components on the motherboard have some level of modularity, so there has to be some way that all of these can communicate with each other. To be able to communicate between the CPU and memory, for example, the computer has a series of communication paths called a bus. If you look at the bottom of your motherboard, you can see the buses much clearer. You could also see traces that are moving between the different components on your motherboard. And you can see very clearly where the communication paths happen to be. If you're working with an older computer, you may see some expansion slots on that computer that are PCI. This is Peripheral Component Interconnect, and it's a standard that's been around since 1994. PCI has different bus sizes that can be used. There's a 32 PCI bus and a 64-bit PCI bus. And these communicate using parallel communication. This is a type of connector that you might find on legacy devices. You're probably not going to find a lot of PCI interfaces on your newest computers. Our PCI expansion cards not only support different widths, but also different voltages. Some will support 3.3 volt capabilities, and others will support 5 volt capabilities. On newer computers, you probably won't find a PCI bus. Instead, you'll find the newer PCI Express bus. You'll sometimes see they're written as PCI Express with the lowercase e. This effectively replaces PCI and changes the way we communicate across the bus. Instead of a parallel connection, PCI Express uses a serial connection. And the communication path that it uses to communicate between these PCI Express devices is called PCI Express lane. Just as you add more lanes to a highway to support more traffic, you can add more lanes to a PCI Express bus to support transfer of more data. You'll see these lanes to a PCI Express bus to support the transfer of more data. You'll see these lanes referred as 1, 2, 4, 8, 16, or 32-bit full duplex lanes. These are written at the X with the beginning, so you might sometimes see 1X, 2X, 4X, and so on. You would pronounce this with the X being a by. So this is 1 by 2 or 8 by 32, for example. Here's another look at these interfaces on the motherboard. You can see those keys are in very specific spots, so that will only allow the correct card to be installed onto the motherboard. Let's look at the 64-bit card that we had earlier. We know that these are different buses and different lanes that we would use. Here's another motherboard that has PCI Express and PCI. Take a look at the different format and the sizes. They're going in a different direction. One communicates through serial, unidirectionally, and it's slower. The other does not slow down any devices because of duplexity. This image shows the simplicity of a serial connection between devices. This PCI Express 1 lane has one communication path going one direction and another in the other. You can see here that there are 4 lanes. So there are 4 X4 duplex with communication going back and forth between the 4 lanes. Okay, we're at the end of the objective. Here's a pop quiz. What is the maximum duplex of PCI Express? A, X8, B, X16, C, X32, or D, X64? The highest duplex that you can have is X32. We only see this on very high-end devices, maybe like a graphics card, where there needs to be a ton of communication between the motherboard to produce graphics on the display. Thank you for watching.